While it's true that 98% of in-car vibrations are caused by the unbalance of wheels and tires, when a problem arises which cannot be corrected by basic wheel balancing, then, as with all diagnoses, the possibilities are numerous. Add to this the probability that when on the job, there will be more than one problem at a time, and you'll understand that it's only by a careful step-by-step elimination of the likely faults that you will carry out a satisfactory rectification by the shortest route. The Service Training Centre of Chrysler, United Kingdom Limited, has developed this videotape presentation to consider one by one the possibilities. To aid you with your practical work, a memory aid card will be handed out after the program. Keep it, it's yours. Section 1. Types of unbalance. We'll start by looking at the types of unbalance to diagnose, if the probable fault lies in the wheel assemblies, and at the same time remind ourselves of some of the principles involved. If a wheel with extra unbalanced weight is allowed to swing free, the heavy point will settle at the bottom. This is static unbalance. At rest, no problem. But when the wheel begins to turn at speed, it becomes kinetic unbalance. Under the influence of centrifugal force, the weight tries to fly out, in the same way as a weight swings out on a piece of string. This action in a car wheel assembly sets up characteristic vibrations that are unacceptable. At one moment, the wheel is pressed into the road. At the next, it tends to lift off. The wheel is trying to tramp. This conveys a heavy up and down vibration to the whole front of the car, which may also be felt through the steering hand wheel. When the extra weight is on the center line of the wheel, this is kinetic unbalance, and must be corrected before dynamic unbalance can be tackled. Dynamic unbalance is where the heavy point is to either side of the center line, say in the wall of the tire. In this case, centrifugal force acts as before, but because the heavy point is off-center, it also tends to twist the wheel about its steering axis. Combined forces are now at work as the weight tries to swing back onto the center line. As the effect of twisting about the steering axis is reversing the thrust at the steering wheel for every revolution of the road wheel, the predominant sensation, apart from vibration, is a shimmy or wobble effect felt at the steering wheel. While the tramping action of kinetic unbalance is still present, it may not be noticed. Dynamic unbalance can be created by incorrect tire fitting causing runout. The wheel, with its inflated tire, also has a vibration frequency of its own. In other words, it has a tendency to bounce, rather like a tennis ball, at stage A. So when the out-of-balance forces we've talked about match the wheel's natural frequency, they are magnified, shown at stage B. This is why out-of-balance vibrations increase and decrease in both the lower and upper speed ranges. But you may have kinetic and dynamic unbalance, together with wheel and other frequencies, all magnified by one or more mechanical conditions as components begin to wear. Nevertheless, correct lead-up to routine wheel balance and careful attention to kinetic balancing will in most cases take care of all problems. Although detailed wheel balancing procedure is not within the scope of this program, there are one or two points which seem to get overlooked in the preparation work. These in themselves can waste time and cause endless trouble. Remove existing weights. And don't forget mud and stones in the tread and loose material inside the tire. Even balance weights have been found floating loose in there. Incidentally, an on-the-car balancer is to be preferred. And do read the instructions issued by the manufacturer of your particular machine. Those of you who are unfamiliar with the procedure should follow it step by step, whilst the experienced might easily find they're overlooking some finer points. A reread is worthwhile. Mechanical wear was mentioned as a factor a few moments ago. This gains in importance with vehicle age and in difficult cases. On all vehicles, the mechanical factor should be kept in mind during preparation for balancing. In this way, the alert technician, at an early stage, may spot damage or an irregular condition that has a bearing. When it comes to problem cases, lateral and radial run-out of tires will have to be checked to close limits. But at the initial stage of routine balancing, look at fitting beads and spin the wheel to see how it looks. This will pick out the odd case which is hopelessly out. Also, remember that nylon and other synthetic cord tires can develop flats when they stand and cool down from a hot condition. To get rid of flats before balancing, the car has to be driven to run them out. They must be dealt with before balancing. In connection with this last point, inflation to 40 pounds per square inch helps to maintain roundness. But remember to reduce to normal working pressures afterwards. You don't want to frighten or annoy your customer. Besides, there's the question of safety and legal liability. Returning to actual wheel balancing. Having fitted the balance weight, always check that balance is within limits. And make sure the job is right at the time you do it, while the equipment is still set up. Then you never have to come back later if you hit a snag, just in case. Kinetic balancing of rear wheels is sometimes required, but the spinner must not be used to spin driving wheels. If balancing is to be done in situ, the engine must drive one wheel while the other is stationary. This means the differential gears are going to be driven in a manner for which they were not designed. Unless care and special precautions are taken, severe and expensive damage would be done to the customer's axle. Locate the jack securely under the differential and arrange so that one wheel is firmly held by a prepared wood block and the axle is level. The axle must be horizontal or lubrication of differential gears and bearing will suffer. And for safety, chock both front wheels. The next safety point is that the wheel speed must be monitored on the speedometer the whole time. With top gear selected, the speed is increased slowly until the unbalanced speed is reached, and no more. 35 miles per hour on the speedometer must not be exceeded. This is 70 at the wheel. The operator at the wheel balancer must instruct the assistant regarding speed and take his reading as soon as the pointer steadies. The duration of running must be kept to a minimum to protect the differential gears. 30 seconds for spin, maximum of 3 spins per wheel. Finally, the road test either confirms that the routine wheel balancing has rectified the problem or not. If not, it must report in detail on the appropriate paperwork the conditions found as the basis for other diagnoses, pointing the way to further rectification. Section 2. Vibration from the front of the car. Remember, in the introduction to this program, we stressed the need for a careful step-by-step elimination of likely faults. So break down the road test report into sections. Does the vibration come from the front or rear of the car? Dealing first with the front, does it occur all the time or only at certain speeds? The situation is, the remaining minimal unbalance is being magnified by wear or very minor fault conditions. So you've got to get what some might call downright finicky about the checks that follow. In the first condition, vibration of the front of the car at all speeds above 10 miles per hour, probably with movement of the steering wheel. Both kinetic and dynamic unbalance can be involved. So inflate tires to 40 pounds per square inch. Jack up the front of the car and reduce hub end float to 0. Recheck tire fitting beads, then check radial and lateral runout of the tire. You're now working to tight limits. Excessive runout may be due to out of round tire, wrong position on wheel or hub runout. Check radial and lateral runouts of the wheel on the hub, placing the clock stylus in the position shown. If the wheel runout is within limits, but the tire runout is not, mark the high point on the tire and the low point on the wheel, and reposition the tire so that the 2 points coincide, and recheck runout. Now examine the wheel mounting face for irregularities such as heavy, uneven paint runs or weld splatter. Anything that could force the wheel to run out of true on the hub. Check hub runout at the wheel mounting face using the dial indicator as shown. 0 end float is still maintained. The dimensional position of the gauge stylus is important to an accurate reading. Acceptable radial lateral runout at the tire must be achieved. 3 possible causes have been pointed out in addition to tire eccentricity on the wheel itself. This is the most common cause. If the vibration remains, additional mechanical checks must be made. Check steering ball joints and relay lever for wear and renew where necessary. The up and down movement on the relay lever must be measured, as the permissible movement at this point is relatively large. Use the workshop manual and bulletin for details. Now reset hub end floats and with the correct tire pressures, road test. The sequence of vibration shown here, which can also be felt through the steering hand wheel, starts, as you see, at about 45 miles per hour. It then fades at about 55 and reappears again at about 72, finally fading out at about 78 miles per hour. The sequence is due to kinetic or dynamic unbalance being accentuated at these road speeds by engine and front suspension frequencies. So the next step is to visually check engine mounting rubbers for condition and check that correct type mountings are fitted at each side. If on road test vibration was identified to the engine, slacken the engine mountings and exhaust hanger brackets. Run engine up to the RPM at which vibration was noted, allowing the engine and exhaust system to self-align themselves. Then retighten engine mountings and the hanger brackets. Also check that engine and suspension mounting bolts are to the correct torque loading. The details and figures can be found in your workshop manual. If the engine mounting rubbers and suspension and engine mounting bolts are correctly torque loaded, then check radial and lateral runout of the tires and entire wheel assemblies, as was done for the previous problem. Then rebalance and road test. Section 3, vibration from the rear. There are 2 basic situations, and neither is felt at the steering wheel. The first is at all speeds over 35 miles per hour. The second is felt at a period between 45 and 55 miles per hour. These are vibrations through floor panels, felt, so to speak, through the seat of the pants. The basic cause is kinetic unbalance of rear wheels. Very careful attention to preparation, particularly to the radial and lateral runout of tires as previously described, again applies. Remember the 3 precautions to protect your customer's differential gears. Horizontal on jack, top gear, 35 miles per hour maximum, shortest possible time run, maximum 30 seconds. If after wheel balancing, vibration still occurs above 35 miles per hour, attention must be turned to the propeller shaft balance, or run out of the rear axle coupling flange. Start by marking the prop shaft at 90-degree intervals with tape. The operator must note the meter reading and identify and note the position of the mark on the propeller shaft, as shown by the strobe light, while the driver must note the speedometer reading, select neutral, and stop the engine. Check balance first. Support the rear axle in its normal running attitude. A 4-post lift is the most convenient location. The pickup of the balancer is set up under the nose of the pinion housing. With the balancer set to high sensitivity, the driver should select top gear and gradually accelerate to obtain peak reading on the balancer's meter. The operator should tell the driver when this has been obtained. The operator now positions the propeller shaft where indicated by the strobe light and fits 1 Jubilee clip with the screw opposite the out of balance position. This will be at the top. The other clip is positioned with the screw at the bottom, 75 millimeters along the shaft, but displaced 25 millimeters anti-clockwise from the unbalance point, which will be at the bottom. And the balancing procedure is then repeated. If the unbalance has increased, the bottom clip should be moved to a comparable position clockwise. Repeat the operation, always moving the same clip in small increments until perfect balance is obtained. then tighten clips fully. If, when the prop shaft has been balanced, road testing still indicates vibration or boom attributable to the prop shaft, then check the rear coupling, flange face and spigot. Change the coupling if either face or spigot is not within limits. Then repeat the balancing operations. When prop shaft balance is satisfactory on the machine, if a road test should still report vibration, this cannot now be attributed to the prop shaft. Further consideration must be given with particular attention to wear factors. Section 4. How to proceed. Now for a final recap. As we said at the start of the program, 98% of the job is straight wheel balance. This must be put to bed before tackling the remainder. So, unlike many jobs, simple wheel balancing can come before road test. That way you save time. When you're preparing for road test, in addition to all usual checks, etc., bear in mind the reasons for the particular test. Then, when you go out on the road, you'll already know something of the mechanical condition of parts of the vehicle that may come in question. Remember, the test is to prove or disprove the elimination of objectionable vibration. It must cover the ranges under which the vibration complained about occurred. If remaining vibration is found on subsequent tests, it must be described and identified so that the workshop moves in the right direction to effect a cure. A typical example would be vibration in hand wheel, noticeable at 35 to 40 miles per hour and at all speeds above. Vibration at front of car. This is clearly the first condition discussed and calls for further careful attention to front wheel and tire runout and rebalancing. Remember that tire and wheel runout are responsible for a proportion of normal balancing jobs and for a high proportion of the remaining difficult cases. Order of procedure must always keep this in mind, deviating only when, say, a tightness check, a quick job, out of context, may save time. When working to very close tolerances on a difficult case, remember that wheel runout in turn is dependent upon hub runout and correct mating of wheel and hub faces, etc. Finally, correct hub adjustment and a check on all moving parts to see there is no undue wear, particularly at the ball joints and relay lever. Remember, the relay lever is allowed rather more vertical movement than some people expect. So refer to the workshop manual and bulletins to save yourself unnecessary work, which adds to the cost. Make an overall inspection of the steering and suspension for signs of damage and/or looseness of components, and rectify before balancing, as these may magnify an existing problem. Engine and front suspension mountings, torque loading and correct type and position of engine mounting rubbers are critical if vibration at the front occurs in the 45 to 55 miles per hour speed range. If the vibration is at the rear, remember the need for great care to protect the differential during wheel balancing. If the prop shaft is suspect, then check balance, using the Jubilee clip method described. If necessary, go on to check the runout of the rear axle coupling. Throughout this program, one source of vibration has been considered at a time. We mentioned earlier that it's probable that two or more may be involved. Don't let this throw you. Aim to eliminate one at a time. That way you reach your goal by the shortest route. And remember, customer care is our main objective. Finish the job right first time, on time. Report any necessary additional work required, either now or on the next service. Make sure the car is handed over in a safe and roadworthy condition, and that all jobs are signed off before the car is handed to the reception. Leave the car in a clean and tidy condition. In short, treat it as if it were your own property.